Alright, hi guys. Okay, welcome to our last series of videos on mass weight density. We are over here right now on page 76 of your textbook. Okay, so today, right now, we're gonna just finish up on density, the final part of this chapter. Okay, so what is density? Density is basically just made up of two things. It's a combination of the mass of an object versus the volume of the object. Okay, so we can actually draw this triangle method to actually find the formula here. So density, which is a short form for this over here, this is actually rho. Rho is the Greek alphabet. The short form for density is equals to mass over volume. Okay, and we know the SI unit for mass is the kilogram, and SI unit for volume we mean meter cubes. That's why SI unit is actually kilogram per meter cube over here. Okay, I like, as you know, I don't really like this sort of notation. So, do change this. Instead of kilogram, meter minus 3, I would just like to change it to kilogram per meter, and over here, just change it to cube. Okay, okay, just excuse me on this. Okay, so instead of writing this way, okay, do write it this way, so that we don't confuse that. Okay. Okay, so as you can see, this is actually a table of different densities of different materials. You can see one of those, which the highest densities will be gold. It will be mainly solids. Solids actually have got much higher densities than liquids, which have higher densities than gases. So gases will be one of those which has the lowest density, which is why over here for next term, in term 3, we're going to talk about solids, liquids, and gases. So just take note of this first, put this part this at the back of your mind. Okay, we know most of the time that ice actually floats on on the liquids that we actually drink on, whether it be Coke or water. Okay, so because water actually has a density of 1000 kilogram per meter cube, and ice actually slightly lower than that. I don't think they actually. Yes, you can see ice is actually about 0.917, so it's about 917 kilogram per meter cube. So it's slightly less dense than uh, water, which is why actually it's able to float. If you were to change the liquid to turpentine, which has got a much higher density, you can see water has got a density of 1 gram. This in grams per cm cube. Turpentine is all the way here. So turpentine is much less dense, so that's why the ice actually will sink to the bottom. And if we were to change it to mercury, it doesn't just float like over here, it actually goes all the way. Over here is still floating, about 90% of it is actually submerged, whereas over here, if you have to submerge it in mercury, over which is over here, the lower spectrum of liquids, it will actually go all the way to the top. Okay? Um, Okay, so why does a heavy steel ship float? Okay, I'll actually show you a short video after this that will actually be able to explain much better. But the short explanation for that will be actually contains, not if it's 100% steel, it will definitely not be able to float. Okay, but it's able to float because it has a large volume of air inside. Okay, so the Titanic actually sank because there was a hole in the ship, and the ship, a lot of water actually entered it, so the air was actually removed. And as you can see here from the table, if water actually takes over air, look at water. What is the density of pure water? That's the density of pure water. Water takes over air, which is about much lower. You can see, so the density of the ship actually increases, which is why it actually sank. Okay. So why does ship float again? A steel ship float is because the average density of the object of the ship is attained by dividing the total mass over the total volume. So this is just a couple of numbers over here. Volume of the ship is fixed. The mass of the ship is this amount. So if we were to find the average density of the ship, this will be the average density over here, which if you notice is actually much less than salt water, because salt water, the average density of ship is actually less than the density of of seawater. Oh, okay, so 358 kilogram per meter cube is actually less than 1025. Again, this is not 1000 because this is for seawater. So seawater has got a lot of salt in it, which is why it's slightly higher than water. Okay, therefore the ship is able to float because over here the mass of the ship, most of it is not steel alone. It's actually there's a lot of air, and the mass of air is actually very, very light. Okay. Alright, so here's one example here. They give you a block of concrete with these dimensions, having this density. Can we find its mass? Okay, so using the formula, we just use the triangle method again. So mass is simply density times volume. So given the density, given the volume, just multiply it, and that will be the mass. Okay, so just a recap on this entire chapter. Over here we are at page 79, at the top of page 79. Okay, the inertia of an object, to highlight these parts. Inertia of an object is the reluctance for it to move, okay, or change the state of motion or due to its mass. Okay, mass is a measure of inertia. Larger the mass, greater is inertia. And density is basically its mass per unit volume. It's measured in kilograms per meter cube. And this is the formula over here. Density equals mass divided by volume. Alright, so just a mind map for this chapter. Okay, we talked about mass first. Mass is defined as amount of substance in the body, and it's also a measure of amount of inertia. The larger the mass, larger the inertia. Okay, mass is also related to density and weight. Okay, you can see the main difference between weight and mass. We actually covered that. And weight is actually a function of its mass. That means it's defined as the gravitational force acting on it. And you can see here, it's actually related to its mass. The higher the mass, the higher the weight. Okay, but it's also related to G, which is the gravitational field strength, which is G, and this is defined as the gravitational force acting per unit mass. So gravitational field is a region where mass experiences a force due to attraction. Okay, so there's a difference here between gravitational field and gravitational field strength. Basically, gravitational field is a region where a particular mass has got a force. So you can be on Earth, you can actually have a gravitational field. You can be in the moon, you actually have a gravitational field because you still have weight there. But if you're in space where there's no Earth, no planets nearby, you actually feel weightless, which is why there's no gravitational field. And how do you know, how do we measure that? We actually look at gravitational field strength. So we measure that based on the value G, which is defined as the force per unit mass. Okay, and we finish up with density. Okay, in this video, density is just equals to mass divided by volume. You can actually use the triangle method again to find either of these variables. Alright, so just finish off with the next video. The final video is just to talk a little bit about density and to explain to you a little bit about the difference between density and how heavy an object is. Okay, hope you enjoyed this series of videos. Alright, and I'll see you soon. Bye-bye.